slope equals average rate of change. What about this case? If your function is not linear, like this, slope is actually what? Instantaneous rate of change, not actually average rate of change. What's the instantaneous rate of change? We talked about that. This is actually summary, right? Yeah, this is the instantaneous. That's 4.4. This information is actually what, at the end of 4.3. Yeah, over this information. Then start instantaneous rate of change. And the important question is this: why we need instantaneous rate of change rather than average rate of change? So I want you to read some information here. As I said, yeah, this textbook is very basic, but not many textbooks, I think, explain this precisely, very precisely explain very important concept. So good to good to read and understand, practice, following this textbook explanation, example, and we already talked about actually the concept of instantaneous rate of change. Remember, yeah, this information, right, from here. Right? Okay, let's briefly talk about why we need the instantaneous rate rather than average rate. Uh, 166, bottom of 166. Maybe not easy to understand at the beginning, but so as he says, average rate of change is not sufficient to analyze the reality. What about real world? Sometimes events change so rapidly. Weekly change, daily average, weekly average, daily average, even hourly rate average, even the secondary average. That's the concept. That's why we need the instantaneous rate of change. We need actually what the change, the rate of change. The rate of change not between this kind of two points. 2 points. What's the concept of instantaneous rate of change? Look at this. This is important concept of instantaneous. Computing average rate of change when the change in x is what, smaller and smaller. Smaller and smaller, especially this case. Yeah, we talked about this before. Yeah, this is what the secant line. Secant line connects what, 2 points, right? So the starting point is 2, and the ending point is whatever the value is. As we said, h is variable, right? It could be 1, it could be 2, 4, 5. And what's the instantaneous rate of change? Simply speaking, the tangent line, right? The slope of the tangent line, that's the actually derivative. But the concept is, if this secant line actually were closer and closer to the tangent line. In other words, if h is what? Difference between these two x points, right? When h is what, smaller and smaller. So when 2 plus h is almost like what, similar to 2, approach 2. What's the slope of this line? That's the actually tangent line. That's the actually the slope. If function is nonlinear. So this concept is very important. It is starting from what? Computing average rate of change between 2 points, but if the h is smaller and smaller, interval is smaller and smaller, Then the slope of the secant line between 2 points becomes what? Slope of the tangent line, if h is smaller and smaller. And this concept, this expression is same as this. Slope of the tangent line, this is tangent line, right? This point, like this. Same as slope of the curve at a point, when x equals 2. In this case, x equals 1, right? 1. Let's say this is 1. So same expression, slope of the tangent line is tangent line, and the slope of the curve at a point. Slope at a point, that's the actual concept of instantaneous rate of change. Instantaneous rate of change, or the word slope of the nonlinear function. Slope at a point. What about the average rate of change? Slope between 2 points, like this. That's the average rate of change. Slope between 2 points. Versus what? Slope at a point. That's the instantaneous rate of change.